Hey, my name is Troy Bach. I am doing my lab 4A. My lab 4A, as we can see, give me one moment. I believe I had it here in files. It is. Hold up, please forgive me. Alright, there it is. Alright, for my laboratory 4A, we are asked to um implement a Quartus file named lab for last name, create a adder, create a block for said adder, create a 5-bit adder, carry two inputs into 5-bit adder into the 6-bit display into a DE0 hexadecimal format. That is what we are asked to do. And also, full adder, create a block adder, boom, boom, boom. Okay, cool, cool. So I'll just start by showing you my Quartus code. First, you could see right here, this is my full adder. It's, basic input A and B, C in, some C out. It is in Verlong code. Assign out AB. This is my 5-bit adder. You could see the input as the 4O, the 5 input A, 5 input A, no, 5 input A, 5 input B, 5 input sum overload, the overflow, the internal carry wires, um, and this is my hex converter. I believe that was the dual 7-segment hex display. No, 7-segment hexadecimal display code converter in Verlong code. Yep, 4-bit input and 7-segment output, as you can see. And then after that, in our Verlong 4 file, we have our adder, the top part of our adder with the inputs and the 7-segment high digit and instance 4-bit adder. For the sake of time, you could just look over this. And then finally, we have our test bench, and this is what we ran. Said correctly compiled files on, and they all compiled correctly as such. And then when I ran the RTL simulator with a little bit of troubleshooting, I was able to acquire this formula in Questa where it alternates, and see if we could change the color here. Thinking purple, midnight purple, light blue, apply, okay. I do not see the alteration of that color specifically, but here is our Questa design. It's a lot of files. I'm mildly colorblind, so if you see that coloration, let me know. We can zoom out. That's what it looks like. Zoom in and full zoom. And so yeah, that is our main thing. Cool. Um, let's see. Hey, really quick, I forgot to add this. So the symbols for my code, I'm showcasing in the way I align them. I'm adding this at the end of, but you already see my code worked and function in Questa. Um, so anyway, let's start with my adder. This is how I formulated my adder, where we have our inputs. Each of them have a NOT gate, and they're connected to precisely seven different AND gates. Um, 4 AND gates have 3 inputs, and then 3 AND gates have 2 inputs, and then the 3 2-input AND gates connect to an OR gate, and the 4 3-input AND gates connect to a 4-input OR gate, and both of them are connected to outputs. I've taken this specifically and made it into the full adder symbol you see, and I've taken 5 of them and put it into the circuit. As asked in the thing to create a 5-bit adder from 5 volt adder blocks and carry out to the 6th display. I have done this, and then I've taken the 5-bit adder, I condensed it into another symbol, and then my 6-bit display is being input, and then the adder is connected to the ground, and then it outputs into my 6-bit display. And yeah, that is my symbolized code condensed into into the into the two 7 segment display decoders, which I have in Verlong code, which I had showed you earlier, and you see my test bench works. So yeah, I just um formatted it this way, and I want to show you I did it both ways with I've Verlong the adder, and I also manually created the adder as well. All right, cool.